The situation involves troubleshooting unusual electrical readings encountered at a residential property. The initial report indicates a Maytag combo washer/dryer unit malfunctioning after 7 months of use, with a Maytag technician suggesting a neutral issue under load. Upon investigation, a 10/2 with ground wiring configuration connected to a 3-prong dryer receptacle was found. Voltage measurements reveal 240 volts between the ungrounded conductors, 126 volts from one conductor to ground, and 105 volts from the other conductor to ground. The bonding strap connecting the terminal block center lug to the fray was properly connected, consistent with the 10/2 feed. Further measurements indicated 120 volts to ground to the 30 amps breaker feeding the unit. Plugging in the appliance resulted in readings of 3 volts to ground on one leg and 238 volts to ground on the other. A possible explanation for these readings is an open heater coil within the dryer. Several factors could contribute to these unusual voltage readings. Firstly, an open heater coil in the dryer could disrupt the neutral voltage, leading to the observed measurements. When the coil opens, it interrupts the current path within the neutral conductor, resulting in an elevated voltage on that leg. Secondly, loose or corroded connections at various points, such as the bonding strap, terminal block, or within the electrical panel, can introduce voltage imbalances and dropouts. It is essential to thoroughly inspect and tighten all connections to ensure proper conductivity and electrical continuity. Thirdly, the possibility of an unauthorized neutral tap upstream of the measurement location should be considered. Such a tap would create an alternative path for current flow, potentially reducing the voltage drop at the appliance. A careful examination of the wiring in the surrounding area is necessary to identify any such unauthorized taps. Fourthly, while the ground connection in the panel was checked, a problem may still exist within the panel itself. Issues such as a loose or damaged neutral busbar or a faulty circuit breaker can contribute to voltage fluctuations. A comprehensive inspection of the panel by a qualified electrician is recommended. Fifthly, although less common, fluctuations in the power supply can occasionally cause temporary voltage imbalances. Significant fluctuations could impact the operation of appliances. Monitoring the voltage over time can help determine if this is a contributing factor. Recommended actions include: firstly, contacting Maytag to schedule a qualified technician to diagnose and repair the appliance. Secondly, meticulously checking and tightening all connections throughout the circuit, including the bonding strap, terminal block, and within the panel. Thirdly, carefully inspecting the wiring in the area for any unauthorized taps that may be diverting neutral current. Fourthly, arranging for a qualified electrician to conduct a thorough inspection of the electrical panel to rule out any internal issues contributing to the voltage imbalances. Fifthly, monitoring the voltage over an extended period to determine if there are any ongoing fluctuations that may require further investigation. The 2008 National Electrical Code, or NEC, provides guidance on proper wiring methods and grounding requirements to ensure safety and prevent electrical problems. Article 250 covers grounding and bonding, outlining requirements for grounding electrode systems, equipment grounding conductors, and bonding of metal parts. Article 300 addresses wiring methods, including requirements for conductor insulation, protection, and installation. Article 400 covers flexible cords and cables, specifying their permitted uses and limitations. Article 406 pertains to receptacles, cord connectors, and attachment plugs, including requirements for grounding and polarity. Article 422 addresses appliances, including requirements for wiring, overcurrent protection, and grounding. Article 550 covers mobile homes, manufactured homes, and mobile home parks, outlining specific requirements for electrical systems in these structures. Article 551 pertains to recreational vehicles and recreational vehicle parks, addressing electrical safety in these environments. Article 600 covers electric signs and outline lighting, including requirements for wiring, grounding, and overcurrent protection. Article 680 addresses swimming pools, fountains, and similar installations, outlining specific requirements for electrical safety near water. Article 690 covers solar photovoltaic, or PV, systems, including requirements for wiring, grounding, and overcurrent protection. When dealing with electrical issues, it is crucial to prioritize safety and follow proper procedures. Always disconnect power to the circuit before working on any electrical components. Use appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses. If you are not comfortable working with electricity, it is best to consult a qualified electrician. Understanding voltage drop is essential for electrical installations. Voltage drop refers to the decrease in voltage that occurs along a conductor due to its impedance and the current flowing through it. Excessive voltage drop can lead to various problems, including reduced appliance performance, overheating of conductors, and premature equipment failure. NEC Section 210.19a1 provides guidance on voltage drop limitations for branch circuits. The recommendation is that the voltage drop on a branch circuit should not exceed 3% at the furthest outlet for power, heating, and lighting loads, or a maximum of 5% for the combined feeder and branch circuit. Several factors influence voltage drop, including the conductor's length, cross-sectional area, material, and the current flowing through it. Longer conductors, smaller conductor sizes, and higher currents result in greater voltage drop. To minimize voltage drop, it is essential to select conductors of adequate size for the intended load and distance. The NEC provides tables such as Table 8 and Chapter 9 that list the ampacity of conductors of various sizes and materials. These tables should be consulted when selecting conductors for electrical installations. Additionally, reducing the length of conductors and minimizing the number of connections can help reduce voltage drop. Voltage drop calculations can be performed using Ohm's law and the conductor's impedance. Ohm's law states that voltage volts equals current amps times resistance ohms. The resistance of a conductor can be calculated using the formula R equals ρ times L divided by A, where R is the resistance in ohms, ρ is the resistivity of the conductor material in ohm meters, L is the length of the conductor in meters, and A is the cross-sectional area of the conductor in square meters. Online voltage drop calculators can simplify the process of calculating voltage drop for various circuit configurations. These calculators typically require inputs such as the conductor's length, size, material, current, and voltage. Understanding and managing voltage drop is crucial for ensuring the safe and efficient operation of electrical systems. By selecting conductors of adequate size, minimizing conductor length, and reducing the number of connections, voltage drop can be minimized. Grounding and bonding are essential safety measures in electrical systems. Grounding provides a low impedance path for fault current to return to the source, allowing overcurrent protective devices, such as circuit breakers, to quickly trip and clear the fault. Bonding ensures that all metal parts of an electrical system are electrically connected, minimizing the risk of electric shock. NEC Article 250 provides comprehensive requirements for grounding and bonding. The grounding electrode system typically consists of a ground rod, ground plate, or underground metallic water pipe that is connected to the building's electrical system. The grounding electrode conductor connects the grounding electrode to the neutral bus bar in the service panel. Equipment grounding conductors provide a path for fault current to return to the source from non-current carrying metal parts of electrical equipment. Bonding jumpers are used to connect metal parts of electrical equipment to the grounding system. Proper grounding and bonding are crucial for protecting people and equipment from electrical shock and fire hazards. Regular inspection and testing of grounding and bonding systems are recommended to ensure their effectiveness. Overcurrent protection is another essential safety measure in electrical systems. Overcurrent protective devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a predetermined level. This protects wiring and equipment from overheating and potential fire hazards. NEC Article 240 provides requirements for overcurrent protection. Circuit breakers are electromechanical devices that automatically trip and interrupt the flow of current when an overload or short circuit occurs. Fuses are overcurrent protective devices that contain a fusible link that melts and interrupts the flow of current when an overload or short circuit occurs. The size of the overcurrent protective device must be matched to the ampacity of the circuit conductors. The NEC provides tables that list the ampacity of conductors of various sizes and materials. Overcurrent protective devices must be readily accessible and properly labeled to indicate their function. Regular inspection and testing of overcurrent protective devices are recommended to ensure their proper operation. Short circuits and ground faults are common electrical problems that can cause significant damage. A short circuit occurs when there is an unintended connection between two conductors of different potential. A ground fault occurs when there is an unintended connection between a conductor and ground. Short circuits and ground faults can cause a rapid increase in current flow, which can lead to overheating of conductors, melting of insulation, and potential fire hazards. Overcurrent protective devices are designed to quickly trip and interrupt the flow of current during a short circuit or ground fault. Ground fault circuit interrupters, or GFCIs, are special types of circuit breakers that are designed to protect people from electric shock. GFCIs monitor the current flowing in the hot and neutral conductors of a circuit. If there is a difference in current of 5 mA or more, the GFCI will trip and interrupt the flow of current. GFCIs are commonly used in bathrooms, kitchens, and outdoor locations where there is a risk of electric shock. Arc faults are another type of electrical problem that can cause fires. An arc fault is an unintentional electrical discharge between two or more conductors. Arc faults can occur due to damaged wiring, loose connections, or faulty appliances. Arc fault circuit interrupters, or SIs, are special types of circuit breakers that are designed to detect arc faults and interrupt the flow of current. SIs are commonly used in bedrooms and other areas where people are likely to be sleeping. Electrical safety is paramount when working with electrical systems. Always disconnect power to the circuit before working on any electrical components. Use appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses. Never work on electrical equipment in wet or damp conditions. If you are not comfortable working with electricity, it is best to consult a qualified electrician. Regular inspection and maintenance of electrical systems are essential for preventing electrical problems. Check for damaged wiring, loose connections, and faulty appliances. Replace any worn or damaged components. Have a qualified electrician inspect your electrical system periodically to ensure that it is safe and in good working order. When troubleshooting electrical problems, it is essential to follow a systematic approach. Start by gathering information about the problem. Ask questions such as when did the problem start, what are the symptoms, and what has been done to try to fix it. Next, inspect the circuit visually for any signs of damage, such as burnt wiring or loose connections. Use a multimeter to measure voltage, current, and resistance. Compare your measurements to the expected values. Consult the NEC and other relevant standards for guidance on proper wiring methods and safety requirements. If you are not able to identify the cause of the problem, consult a qualified electrician. The information provided is intended for general guidance only. It is not a substitute for professional electrical advice. Always consult a qualified electrician for any electrical work. Additionally, always comply with the relevant electrical codes and standards in your jurisdiction. In this specific case, the presence of 240 volts between the ungrounded conductors is expected in a standard 240 volts circuit. However, the readings of 126 volts and 105 volts from each conductor to ground suggest an imbalance, which could indicate a problem with the neutral connection or a load imbalance. The fact that plugging in the unit results in readings of 3 volts and 238 volts to ground further suggests a problem with the neutral or significant load imbalance within the appliance.